Hello everyone, myself Dr. Ranjith Kumar Gatla. I am working as an associate professor in Department of Electrical and Electronic Engineering, Institute of Aeronautical Engineering. Today we are going to discuss about the operation of switch mode regulators. So this is the last topic in the module 3, which is DC to DC converter. Now let us discuss. Before that, what is a switch mode regulator? The basic function or the main function of the switch mode regulator is it converts the unregulated DC supply to the regulated DC supply. It converts the unregulated DC supply to the regulated DC supply. So usually, as we know, the DC to DC converters we can use to convert the fixed DC to variable DC. But that variable DC may be regulated or may or may not be regulated. So which means sometimes it may be unregulated. But if we use these switch mode regulators, by using these switch mode regulators, we can get the regulated DC supply. So here, as I mentioned, which means this switch mode regulator is also a DC converter that can be used as switch mode regulator to convert a DC voltage, which is usually unregulated, to a regulated DC output voltage. And here, how to achieve these regulated DC voltage then? Of course, here that we are mentioning that by using the switch mode regulator, we are getting getting unregulated to regulated DC output voltage. Until now, we have discussed different types of DC to DC converters, which are like the step-up converter, step-down converter, or class A, class B, class C, class D, class E, different types of DC to DC converters that we have discussed. In all these converters, the chopper switch that we are considered as is thyristor. In all the DC to DC converters, either it may be step up or step down, or like boost or buck boost or buck converter, whatever it may be, in all these different types of DC to DC converters, we have considered the chopper switch or the semiconductor switch, which we are considered as a thyristor. But here, unlike the other DC to DC converters, in switch mode regulators, normally we use the switching device as either it may be BJT or MOSFET or IGBT, which means full controlled switches that we are using. Because as we know, the thyristor is a semi-controlled switch, but here the BJT or MOSFET and IGBT are the fully controlled switches, which means we can control turn on and turn off. Both we can control. Then how we can achieve these regulated DC supply? Usually by using a PWM technique at a fixed frequency. PWM, which means pulse width modulation technique. By using pulse width modulation technique, we can get or we can convert the unregulated DC supply to regulated DC supply. And again, when we can apply the PWM technique, it is very easy to apply when we use the switching devices are BJT, MOSFET or IGBT. So which means the configuration of these switching mode regulators or the circuit configuration of these switching mode regulators as well as the other DC to DC converters are almost looks like same, but only the difference is there we use the different types of controller, because as we discussed with the chopper control techniques, one is frequency control, which means time ratio control, and another one is the current limit control. These are the two different techniques that we have discussed to control the choppers. And again, in the time ratio control, One is constant frequency time ratio, and another one is the variable frequency time ratio control, and the other one is the current limit control. So these control techniques we can use when we consider the switching device as a thyristor. But here, these regulated power supply that we can achieve by using the PWM technique. So here the PWM technique is, which means the pulse width modulation technique, is also a kind of control technique for the DC to DC converter. So that's why here in the in a regulated or the switching mode regulators, we are using the BJT, MOSFET or IGBT, which means the full controlled switches. And here you can see the basic structure of the switching mode regulators. Of course, there are different types of switching mode regulators are there, but we are not going in detail about the different types. But here I am trying to give you the basic idea about the switching mode regulator. So here these are the different elements present in the switching mode regulator. As you can see, the DC chopper is there, and in addition to this DC chopper, here to apply the PWM technique, we are using the different components. We are using different components or elements, which are, here it is some control unit and amplifier, and this is some adder, which means we can get some adder or subtraction based on the input signals. Okay, we can get the different function here by using this. Then here, as you can see, this is the input that we are giving, and this is the output that we are getting. Normally, without these unit, this is simply a DC chopper, which means the input is a fixed DC and the output is the variable DC. But this variable DC is usually unregulated DC. But we want to get the regulated DC for this particular chopper. So to get the regulated DC chopper, so what we are going to apply? We are going to apply the PWM technique, that is pulse width modulation technique. Then how we are applying the pulse width modulation technique? By using these different elements, which is controlling unit, amplifier and reference. Here, as you can see here, then now the output we will consider in between these 2 points, plus and minus. So here, this is the reference signal that we are taking, which means the reference output. Reference output, let us consider we need the reference output, which is regulated like this. Okay, so regulate, what is mean by unregulated and regulated means, like in unregulated, the DC supply is maybe like here it zigzag. Okay, the regulated is nothing but like here it is a constant. Okay, so like unregulated to regulated. So here, for a particular input, okay, so we require a particular output. Let us consider this is the particular output that we require. Here, that required output we are taking as a reference. But here, the actual output we are getting from this chopper is from here. So we are just comparing the actual output and the reference output. The reference signal, the actual signal and the reference signal. If the actual signal and if the actual signal is same as the reference signal, then here the error is 0. The error is 0 because let us consider in numerical values. So suppose here 10 volts is our reference voltage, but here our actual output also, if you get the 10 volts, then 10 minus 10 0, so error is 0. But if we get not a 10, let me consider 9 or maybe 11, so that you will get plus or minus 1 error. So we have to eliminate this error. We have to nullify the error by using the control signal. So that's why here this amplifier amplifies the signal, which means it will convert to the suitable signal to the controller, and then the controller will take care, and according to these error signal, it will give a signal to this DC chopper, which means again DC chopper. Suppose here, let me consider, here we are using PWM inverter. So for that, as we know how the PWM inverter, the PWM technique will work. Okay, pulse width modulation. There one is reference signal is there and carrier signal is there. So by changing these signals amplitude or the frequency, of course, anyway here we mentioned it is at constant frequency. which means at fixed frequency. So we won't change the frequency, but by changing the amplitude or the time period, we can change the pulse width of the particular pulse which is given to the DC chopper. So according to that, we are regulating the output voltage by taking the reference signal. This is how usually the switch mode regulator will work. Actually, there are different types of switch mode regulators are there. Same like the DC to DC converters. These are the buck regulator, boost regulator, and buck boost regulator. So actually, there is no difference between almost. Of course, there is a difference, but other than the regulated DC voltage or other than the regulated DC output voltage, there is no difference between the normal buck regulator and these normal buck converter and the buck regulator. The only difference is in the buck converter, we use the chopper switches as a SCR and the controlling technique as a either it may be time ratio control or the current limit control. But in buck regulator, we are using, instead of the thyristor, we are using either MOSFET or IGBT, and the controlling technique that we are applying the PWM controlling technique. These are the only difference between the normal buck DC to DC converter, normal buck converter, and the buck regulator. Right? Okay. And then one more thing. And another basic idea about how how we can convert the unregulated DC supply to regulated DC supply by using the switching mode regulator. Usually, the switching mode regulator consisting of inductor and capacitors, because as you can see in the buck converter or the boost converter or buck boost converter, we are having, in addition to the chopper switch, we are having inductor and the capacitors. So by using these inductor and capacitor function, we can get the regulated power supply, which means, as we know, the inductor and capacitors having the charging and discharging capabilities. So by considering or by taking this charging and discharging capability of the inductor or capacitor, so we can convert the unregulated DC voltage to regulated DC voltage. How we can convert? So let us consider one capacitor. Here, this is the capacitor, and the capacitor is connected across an unregulated DC supply, and also across the capacitor we are connecting one load, and in between these unregulated DC supply and the capacitor, we are placing one switch, one chopper switch. Let us consider IGBT or MOSFET. Let us consider this is IGBT, because in the switching mode regulator, we use either IGBT or the MOSFET. So let me complete this circuit. This is the circuit. So initially, suppose if you turn on the IGBT or if you turn on the switch 1, then in case 1, if you turn on the switch 1, so whatever the supply voltage that you applied across this capacitor, the same output, the same voltage will appear across this capacitor. So let me consider, which is VC. So here VC is equal to VDC, and the which means the current flowing through it, and then the capacitor voltage gradually rises and it will reach certain value. Okay, so that which is equal to VC is equal to VDC. Then the capacitor will stop charging. Then when the capacitor reaches to the supply voltage VDC, then let me turn off the switch. Let me turn off the switch. So here, while turning on the switch, here the capacitor is charged fully. Then now it starts to discharge through the load. So before it was plus and minus, it is charging. So while discharging, again it will change the terminals, okay, with minus and plus, then it will discharge through the load. So while discharging, it will supply, which means here these capacitor will act as a source to this particular load, or this capacitor will supply the energy to this load. Then while supplying the DC supply to this load, here the capacitor will give a regulated DC voltage to this load. A regulated DC voltage to this load. So that's how here the switch mode regulator will work. Because of course here more or less the chopper function is also same. Right? The chopper function is also more or less same. So here switch mode regulator function is also same. But the only difference, as we discussed before, so here in the switch mode regulator, we use the full control switches, and the controlling technique is the PWM controlling technique. So that's why here this is switch mode, because by operating the switch, and again when the capacitor fully discharges, then again we will turn on the switch, then again the capacitor start charging. So this cycle will repeat, so that we will get the regulated DC supply. So how we are getting this regulated DC supply? By operating this switch. That's why this is a switch mode regulator. That's why this is called a switch mode regulator. And now you will see one by one what is buck converter and what is boost converter, or what is buck regulator and what is boost regulator, and what is buck boost regulator. So as I told you here, initially let me consider the buck regulator. So here this buck regulator circuit diagram is same as like the buck converter or the step down converter, because as you can see here it is having one switch, one diode and inductor, and this capacitor is of course it is optional that we have connected across the load, right? So here the here the inductor plays a major role to provide a regulated DC power supply to this load, right? Then when coming to the operation, initially let us consider, because here you can see here we have used the MOSFET. Okay, MOSFET is the chopper switch. So in the first case we are turning on the switch S. Then during this time the load current will flow in this way, as I have indicated with this green line. This way it will flow through the load, as well as at the same time this capacitor will also get charged, because here the same input current will flow. Some of the current will flow through the load, which is called as I0, and some of the current will flow through the capacitor, which is called as a IC. Then during the turn on time, the capacitor will get charged, as well as this field also expands, which means this inductor will also charge with these polarities, which I have mentioned, plus and minus. And the capacitor is also charging in this direction, because here it is plus and minus in this direction, right? Then because here the diode is in the reverse biased, so that's why it won't allow to flow the current, okay, to flow this load current or any other current. So that's why this diode is in the reverse biased. Then when the switch is turned off, during this time the inductor will act as a source, and during turn on time the inductor stores the energy, and whatever the energy stored in the inductor, now that will dissipate through again this load. And again during that time, during when the thyristor is on, this capacitor also charged. Now it is discharge. So which means here it will discharge like this. So which means now the capacitor as well as the inductor will act as a source to this load. So then the load current will flow, when the inductor will supply to the load, as well as the capacitor will also supply to the load. Then this time the diode will get into the forward bias, because here the switch is turned off. So there is no way to close this loop. That's why then the load current will flow through this diode, then the diode will get into the forward bias. Same principle like the buck converter or the step down converter. Then what is the equation, the output voltage equation in the step down converter? That is V naught is equal to delta into V in, where here delta is the duty ratio, which is equal to T on by T. So by changing, of course, here whatever the voltage that we are getting here, it is a regulated DC supply, regulated DC voltage only that we are getting. But again, in the that is the only difference between the normal converter and the switch mode regulator. But other than that, here also the output voltage is also variable output voltage only. Then how we can vary the output voltage? Again, the same like in the what is that, the DC to DC converter, how we changed by using this duty ratio only. So here also by changing the duty ratio, we can change the output voltage, the output regulated DC voltage. This is how the buck regulator will work. And when going to the output voltage equation, as you can see, so of course here, as we know, here we are giving the pulse to the MOSFET, so that's why it is switch on, and again here we are removed, so switch off, and again here we have given on, which means these are the pulses. By using PWM technique, we are generating the pulses, and the same pulses we are giving to the MOSFET, right? So as you can see here, the output voltage, of course here output voltage is not present, but the output current, as you can see here, it is constant, which means the regulator. But in normal DC to DC converter, the output voltage and current were like this, unregulated. But by using this switch mode regulated converter, then we are getting constant, which means the regulated DC output voltage. Then similarly, some other points that I would like to mention for this buck converter. Actually, in the buck converter, there is a problem that the voltage ripple, we will get the voltage ripples, and the voltage ripples can be reduced by increasing the switching frequency. But by increasing the switching frequency, the switching losses may increase. So that is one of the drawback in the buck regulator. And when coming to the advantage, the buck converter needs only one switch device, and it is very simple. Okay, and we can operate at high frequency, which means very fast. So that is also one of the advantages of this buck regulator. And of course, same like in the DC to DC converter or the step down converter, in the buck regulator also the output is regulated by varying the duty cycle. And here I have listed some of the applications of this buck regulator. We mainly use these buck regulators in the regulated DC power supplies and DC motor speed control drives, because as we know, the voltage control technique is there, right? Armature voltage control technique is there in DC to DC motor. So to give the variable output voltage to the DC motor, by using this buck regulator we can give. So that's why here in the speed control of DC motors, so also we use this buck regulator. Not only buck, I mean any other regulator, and computers and portable instruments and medical and communication devices. These are some applications of these buck regulators. Next, the boost regulator. See here, the boost regulator is similar as it is same like the boost converter or the step up converter, but the only difference is instead of the thyristor, here we have placed MOSFET. And here also there are two modes of operation. One is during the turn on, during switch turn on, and during switch turn off, right? So first in mode 1, let us consider the switch is on and diode is off. Switch is on and the diode is off. So when the switch is on, then the load current will flow only through the inductor. So during this time, the inductor will store the energy. The inductor will store the energy. And in the second case, when the switch is off and diode is on, then here you can see in the load there are two currents are flowing. One is the input current IN, another one is the current caused by this discharging of the inductor. Let us consider IL. So both currents are flowing through this load as well as this capacitor. This load as well as this capacitor. Okay. So then when the switch is turned on and the diode is turned off, that time this capacitor will supply the voltage to this load. Okay. So which means here the current is I in plus IL. Both currents will flow, and some of the current will flow through the capacitor and some of the current will flow through the load. So this is how the function of the boost regulator, which is same like the boost converter. And here the output voltage equation V0 is equal to 1 by 1 minus delta into V in. Again here delta is the duty ratio, which is equal to T on by T. So again here also the output voltage, because here Vn is constant, so only the variable is delta. By changing this delta value, we can change this output voltage. Which means we can regulate the output voltage by changing this delta value. This is in case of the boost regulator. And when coming to the output voltage, output voltage and current equation, same like here. What is that? That's why here you can see, yeah, this is the output voltage and output current waveforms. You can see the same output voltage and output current waveforms, similar like in in case of boost converter or step up converter. Then buck boost regulator. Again here the buck boost regulator is also the circuit diagram is same like the buck boost converter. Here also there are two modes of operations are there. In the first mode, we usually turn on the switch S, and during the switch is turned on. Okay, so again the load current will flow through inductor only, because here this diode is in the reverse bias, so it will not allow the current flowing through the load as well as the capacitor. So that's why the total load current will flow through this inductor only. Not load current, the total input current that will flows through this inductor only. And this inductor will charge up to the input supply that we have given. VL is equal to VL. Then which means that's why during turn on the inductor is directly connected to the source and inductor current rises linearly from I1 to I2. Linearly from I1 to I2. Then in the second case, when the switch is off and diode is on, okay, so because in the previously it was charged like plus and minus, then now it will discharge like minus and plus. Okay, so these inductor will discharge through this load, and in this case this diode will be forward biased, so it will start conducting. So that's why the inductor current begins to flow through L and C, okay, and the diode D, and the inductor energy discharges through the load till the switch turn on again. So how long it will discharge? Till the switch is turn on again. This is how the buck boost regulator. So we can see, now I'm going to conclude about these switching mode regulators. So the function of the switching mode regulator is again DC to DC only, but in normal DC to DC converter, so we are not taking care about whether it is the regulated DC or unregulated DC. It's just converting the constant DC to the variable DC. That's all. That variable DC may or may not be regulated. But in regulated, which means in switching mode regulators, we are using not only just to convert the fixed DC to variable DC, fixed DC to regulated or variable regulated DC, variable regulated DC or unregulated DC to regulated DC supply. And when coming to the major difference between the normal DC to DC converter and the switch mode regulator is, in normal DC to, of course in normal DC to DC converter also we can use, instead of thyristor we can use, the IGBT or the MOSFET. Okay, so it is not mean like we must use only thyristor in the DC to DC converters, which means in a buck or boost or buck boost converter. No, there is no such kind of restrictions are there. We can use any one of the power semiconductor switch. Either it may be thyristor or it may be IGBT, MOSFET, BJT. Okay, any one of the power semiconductor device that we can use in normal DC to DC converter also. But in switched mode regulators, we cannot get the regulated power supply if we use the power semiconductor device as a thyristor. So, but unlike in the normal DC to DC converter, in switched mode regulators, we must use BJT, MOSFET or IGBT. And another thing, in normal DC to DC converters, of course in normal DC to DC converters also you can use PWM control technique. But in switched mode regulators we must use PWM technique. By using PWM technique only we can get the regulated DC supply. So to apply this PWM technique, we are using the different elements that I have mentioned here. This is about the switched mode regulators. In next class, we will discuss another topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.